Okay, let's look at these Boolean expressions and try to simplify. We've got A here, and with A we've got these three individual Boolean expressions that we want to place in this Karnaugh map here. So I'm going to just color code it to make it simple. I'll make that one green, the next one yellow, and the last one blue. So I'm going to look where A and B are both true, or 1 in this case. A is 1 here, so it will be anywhere along here, but also where B is 1, which is here and here. So the intersection will be those two. And then for the next one we're looking at is that we've got A and not C. So A again, so it's on this line here, and not C. So not C, C is off on here and on here. But we're not going to write another one here because there's already one in place. So we're going to put one over here. So that's going to be the yellow in this one here. And then finally, we've got A. So where A is 1, so again on this line, and not B. So not B is here and here. So it would be these two. Again, I've already got something there. So we'll put the B in that position here. And as you can see, this is going to work out nice and simply for us. We'll draw a box that's going to go over all of these ones here. All of those together, we're going to simplify. We'll look to see what stays the same. It's A is 1 across all of them. These are always changing. So the answer for this is that ultimately it will simplify to A. In the second question, the one things that are different is that for the first one, because we had combinations of 2 in a 3-variable Karnaugh map, each of them were 2 boxes. Now for here, we've got 3 variables, so that will just be 1 position. That will be 2 positions, and that will also be 1 position. I'll do the same again. I'm going to color code. You don't need to do this in your exam. I'm simply doing this to make it easier for you to see what it is that I'm doing. So we take each of them in turn. So first of all, we're looking for the intersection of A being 1 and B being 1 and C being 1. So A is 1 here, B is 1 here and here, but C is 1 is there, so it's just going to be that one there. So we've got 1 green put in position there. The next one is not A, so where A is 0, so that will be on here, and B, so where B is 1. So that will be B is 1 here, B is 1 here and here. So that would be on those two. And then finally we've got A, so on this line, and B, so where B is 1, so that will be that one and that one. So these two, and not C, so that one there. So B will go in there. Boxes can be 1, 2, 4, 8, 16 in size, have to be regular in size, but a 2x2 box is totally acceptable. We've got a 2x2 box. What does it actually show? Well, what we do to figure out what it shows is we see what stays the same. So on this first row, A is 0 and A is 1, so that's not the same, so it's nothing to do with A. On here, B is 1 in this one and on this one, so B does stay the same. In fact, it will be B. But let's finish this off. C is 1 here and 0 here, doesn't stay the same. So in the end, the simplification of this, it would literally be the value B. Okay, so now we're looking at a 4-variable Karnaugh map. The only things that's different is that on this axis, we've got AB, using the same combination of 0, 0, 0, 1, 1, 1, and 1, 0, and CD on this side. Ultimately, you could do A and D and B and C, I guess, would work. But in this case, it's A, B, and C, D. What's important is that you use the combination of 0, 0, 0, 1, 1, 1, and 1, 0, so that only one thing changes at a time. And we're also going to introduce a new concept. So far, we've talked about Boolean expressions requiring boxes to either be in 1, 2, 4, 8, or 16. It could actually be 16 in this size. In fact, it could be the whole thing could be 1, in which case the answer would be 1. Very unlikely you'll get that as a question. What else? That you should make the boxes as large as possible, that the boxes should be regular in size, and that you should make them as large as possible, including overlapping into ones that already exist. The new rule that we're looking at here is something called folding. So we've got these 2 boxes here identified, this one and this one. First of all, take a moment to do this. what is the Boolean expression of that? So you've been given an Boolean expression and asked to place it in here. I'm going to pause the video for a second, try and identify what the Boolean expression for that would be and the Boolean expression for that would be. Oh, I should say as well, when it's a 4-variable Karnaugh map, if there are 4 different combinations, it'll be 1 box. If there's 3 combinations, it'll be 2 boxes. If it's 2 combinations, it'll be 4 boxes, and then 1 combination or 1 thing would be 8 boxes. So this is going to be a combination of 4 things. So what's that? And then what's that? Okay, let's have a go at trying to write this then. So we're doing this top one first. So we can see A and B are both 0. So that's going to be, and apologies again for my handwriting. I do my best. It's just not very good. So we've got not A. What's the next thing I write down with the B? And not B. And then on the other side, C and D are both 1. So it will be and C and D. Okay? Now, if you wanted to combine that with other ones, you put brackets around it, and there'll be ors to combine it. On this one here, similar deal, except A is 1 and B is 0. So that will be A and not B. Whoops. And then we've got the C and the D. Is that going to be any different? No. So that's also going to be and C and D. And it says, and then the question was, write the Boolean expression represented by the map in its simplest form. And this is where I'll introduce this new concept of folding. So currently, with the knowledge we have, how can we simplify this?
We can take out A because A changes.
Sure, but looking at it, using our knowledge of boxes and the way we draw boxes and make it as big as possible, how many boxes could you draw? Or would you have to draw? 2, absolutely. So this is where folding comes in. Essentially, something on this side can fold over to here. Something on this side can fold over to here. So it can fold over. So if I represent that with the green here, basically it folds over here and it folds back on the other side there. And you do the same thing you do with any other box. You say what stays the same. Do C and D stay the same? Yeah? Does A stay the same on both sides? Does B stay the same? Does B stay the same? So it will be not B and C and D. Make sense? Awesome. Okay, let's try apply some of that logic here, using folding potentially even. Try and simplify that to the simplest form, so it's already been placed in here, the simplest Boolean expression that you can do. Okie dokie, let's look at this question then, shall we? So we're going to use the new knowledge we've had to make the boxes as large as possible in 1, 2, 4, 8, 16s, regular, overlapping, and folding. So I would say we'll take this box, and then what we're looking at is potentially doing a blue here and a red here. Now we can improve the blue by going into a larger and overlapping on here. However, using our new knowledge of folding, what we can do instead is we can fold this red one at the top here and use it to fold onto the other side. So we can take this red and fold onto the other. And there we've covered the two. Beautiful. Let's write that out. Okay, let's have a look at the red and green. Both of them are 2 boxes. If it's 2 boxes in a 4-variable Karnaugh map, how many different variables will I have in each expression? 3, because it's a 4-variable Karnaugh map. A 2 box is a 3, and a 4 box is a 2. So this one here, we see what stays the same. Does C and D stay the same for the red? Yeah. Does A stay the same? Does B stay the same? So we've got C and D and, no, not A. not B.
Oh yes, that one is.
That's quite confusing, actually. It's not B, it's A. No, wait a minute. Or, and then the green one, what stays the same? A and B. It's 1 and 1, stays the same. So we've got A and B. And, does C stay the same?
No.
Does D stay the same?
Yeah.
So A and B and D. What a wonderful world. Okay, people. So we've kind of gone full circle. We were having the kind of questions we had with the 3-variable Karnaugh map. But now with a 4-variable Karnaugh map, we have a Boolean expression at the top. You have to do the first stage, which is put ones everywhere where it's true. Then you have to simplify by doing the boxes using folding, making the boxes as big as possible, 1, 2, 4, 8, and by overlapping. And then find out what the simplified expression is. Best of luck. Okay, well, let's do stage 1 of this, which is going to be putting these Boolean expressions in the boxes. And same as before, I'm going to color code each of these and take them in turn. So I've got the yellow one here. The yellow one says where A is true, which is these two, where B is true, so it's on this row here, where C is true, so this one and this one, so either of these, but also where not D, so it's going to be that one down there. The next one is not A, so not A meaning it's either of these two, so it could be in either of these rows, and C, so one of those, so it's either these two rows and not D, so I think it's going to be, we've got not D there, and then we've also got, so not A, so we've got not A could be these two, and C, and not D, so I think it's those two. And then we've got A and not B. So A and not B is on this row, and C and not D is on this row. So doing the box here, remember our rules, 1, 2, 4, 8, 16, regular shaped, large as possible. We're going to do a 4 by 1, yeah. So we can do all that is one big box. And then what we do is we look to see what changes, what stays the same. Does A stay the same? Does B stay the same? Does C stay the same?
Yep.
Does D stay the same? Yeah, and of course if you do it just a column like a row like that or a column, it will just be essentially whatever that was going to be. So in this case, if I write it out, it will be what? C and not D. And bear in mind, I just want you to appreciate what's just happened. We've taken this with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 logic gates into these two. So that's nice, eh? Okay, so a few more questions here. Give it a go, see you get on. Okay, people, let's try and do this question. I'll do the same as before. I will do this little color coding so we know which is which. For the red, we've got A and B and C, so I'll need to look for the intersection where all three of those are going to be true. And also because there's 3 variables, how big is the box going to be? 2 in a 4 variable. If it was 3 in a 3 variable, it would be 1. All right, so it's going to be here where A and B is true, and C is true here. Oh, sugar, nope. And the bottom 2, or the right 2, so that's 1 and 1. C and D, we've got 2 variables, so how many boxes is it going to be? 4. In fact, it's going to be, if you look at it, all the way down here. We're not going to write 1 on top of the one we've already got. Then we've got A and not C, which again will be 4. So we can look where A is true, so these two, but also where it's not C. So not C is here and here. So we've got these 4 here will be in our box. And then finally, we've got 4 variables, which means it'll be 1 position. I suspect it's going to be here. What do you reckon, guys? Let's find out. So A and not B, which is on this line. C and not D, which is here And there we go. What's the minimum number of boxes we could draw? 2. So we could draw over here and over here. And that is our 2 boxes done using overlapping. And we want to use the overlap, because if we just left those 2 on their own, then we'd have to have 3 variables. But by having all the 4, then we've got 4 variables. In fact, it will still be C. No? Yeah, it will still be C and D. So that's C and D. Hey, what do you reckon this is going to be? It's the one thing that stays the same, isn't it? B goes from 1 to 0. C and D, we know it's going to be, it could be either 0 or it could be 1. D could be 1 or 0. So the answer is going to be A or nope, C and D. So it's a good simplification. Awesome. Okay, so we're having a look at some Boolean algebra using Karnaugh maths for simplification, and I've beautifully written some things here. This is a series of combinations of Boolean algebra that I've separated with ORs, which is the convention about how you can see these type of questions. I'm going to highlight these. Again, you don't need to do this. I just do this to make it life easier in terms of you being able to see it. And I'll go one at a time. So for green, we've got not A and not C and D. So where is A 0? It's here and here. So it could be in any of these 8, but also not C. And C is not here and not here. So it could be any of these 4, but also D when D's on. So it's these 2 here. And then we look at the next one, C and D. Ooh, also it's worth pointing out that in a 4-variable Karnaugh map like this, if there are 2 variables going in, it will mean there are how many ones can be set to 1? 4. Yeah. So C and D, where C and D are true or 1, which is here and here. So it's going to be that whole column going down. And then finally A and not B. And again, that's 2 variables, so it's going to give us 4 ones, where A is 1, these 2, and not B, this one here. So I can go all the way across. So it'll be this row across here. I'm not going to put another one in there, and like that. Wicked. Am I finished? No, I'm not. Stage 2 is simplification. And let's remember the rules of boxes. We make boxes in 1, 2, 4, 8, 16s. They need to be regular, and you are always trying to make the largest box possible, including the use of overlapping and folding. So we want to look for the largest boxes possible. So I'm going to draw the box for this one here. So that's one box. And then I'm going to have a second box, which is all the way over here. Remember, you want to make it as large as possible. So I'm overlapping here to achieve that. And then finally, I'm going to have this one across here, large as possible. And then I need to identify it. So this black box is going to be, remember, you need to look for what changes and what stays the same. Does A stay the same? Yes. Not A is the same for these 2. Does B stay the same? No. Does C stay the same? No. Does D stay the same? Yes. So it's 0 for A and 1 for D, i.e. it's not A and also and D. And then for the yellow one, well, it's actually going to be this original one here, isn't it? Because it's the same column down. So it's C and D. And for the last one, it's the same deal. We've not actually taken anything away. It's still A and not B, right? So it's A and not B for this last one here. So we've simplified, but not tremendously. So let's see if I've done better on some of the other ones. Okay, give this one a try. This time we have 4 combinations against here. I ran out of space. Actually, I didn't. I could have gone along. But it reads along here, and then imagine that this is the next line as a continuation of those ORs. Okay, so very similar question to last time. All of these are the same format, essentially. The only thing that I would say that's different that you should pay attention to is, of course, in here, with some of the sort of the Boolean algebra combinations, there's 4 different variables, which means that it's going to mean how many things are set to 1 on our Karnaugh map. Just 1, yeah, absolutely. So if you've got 4, it's 1. You've got 3, it's 2. 2, it's 4. And I guess 1 would be 8. So let's do the same thing I did before. I'm just going to color code these ones. And then we will have a go at doing it. So the yellow is not C and D. So not C and D is this column here. But and A, where A is true, are these 2. So it would be these 2 ones here. So that's, I'll put the 2 in that one. And then it's for the green, it's not C and D. So not C and D is again going to be here. But now it's not A. So that these 2. But also not B. So it's that one there. And the next one's not A and not B. So not A, not B is on this row here, but also not C. So it's these 2. For the blue, it's not A and not B. So that I mean on this row here, and it's C. Easily confused with not C. And it's going to be those 2 here. And then finally, it's C and D and A and B. So everywhere where it's 1. So this here, the intersection will be that one there. And now we need to try and draw boxes to do this as efficiently as we can. So there are different ways we could go around simplifying it. But it's worth bearing in mind we want to do it with as few boxes as possible, but as few large boxes as possible. And what we could do is cover these 2. So a box around these 2, a box around these 2, box around these 2, and a box around these 2. It's possible, but that would be 4 boxes. Remember, you can also fold. So this can fold over here. Now, you can't do a 3 because that's not allowed, but you could do a 2. So these 2 could fold on top of each other. In fact, I'm going to do that quickly now. So those could fold here. And then with the last 2, we can do that as a 2. And then this as a 2. And again, we can't do it larger because that would be a set of 3 if we went that way. And then we want to identify what those things are. So I'll start with the black box first. So it's 0 and 1 for C. So that stays consistent. So that would be, if it's 0 and 1 for C and D, that would be not C and D to start us off. But of course, we need to also look on the other side. And to complete that off, Joe, what would you go for? What stays the same for A and B?
B.
And it would be, yeah, and what B? Because B is 0 on both of them.
Not B.
Bingo. Thank you, Joe. And then we'll have a look at blue. Lily, what do you reckon? So we can see that we're all on this row here, and A and B are both be on. And the thing will be to look up here and see what stays consistent at the top. So what do you see, Lily? D. And is it negative? Is it not D or D? There you go. And then finally, what would you make this last one? What do you make the yellow box? So C stays the same on both of them, while D does not. So C would definitely be in there. Which means that it's not, yeah, so not A and then not B. Beautiful. Again, I should say, I'm only doing the color coding to make it easier to read. You do not need to be doing this yourself. Don't go into the exam with like 5 different color pens. Okay, so we have more combinations here. We've got 5 combinations, and let's go through them one at a time. I'm going to do the A, B, and not D, and by me saying it, Will do it.
Oh, A, B, and not D. That is going to go in. So A and B, so it's going to be in that row there, and then it's going to be one on the far left, one on the far right.
Bingo. Ethan, not A and not B and D. So not A and not B would be in this row. Yep. And D.
You go on to ideas, which would be the middle two.
Thank you, Ethan. Elijah, blue, not C and D.
So the second column.
Yep.
It's just the whole second column.
Yeah, it's going to go all the way down here, isn't it? You're going to overwrite that red one with the blue one.
No.
It doesn't make any difference, does it really? Just you can't have.
Do this in color, please.
Yeah, it's true. It won't become like 2 or something. It's like, yeah, it's just 1 or not 1 or nothing really. Caden, green, please. Not A and B and not C and D.
It would be
So not A and B is going to be which row?
row 2, column 1.
So row 1, yeah, row 2, and column 1 is not C and not D, so it's going to be that one there. So I'll put the green in. And then finally, Lily, C and D. Agreed. There we go. So I've made something here. What are we going for, and how many boxes, biggest boxes possible? The obvious big box to make is the one in the middle, so let's do that. So we've got one very large one here, and then this is where we can make a mistake, couldn't we? We could do, for instance, one like this. Would that be a mistake?
Yeah.
Why is it a mistake?
You can overlap it by making a
You can overlap it and by making a larger box, and you should always do that when there's the opportunity to do so. And what else? Now, the other mistake we could make, I guess, is just being like, aha, there we go, done. You could either fold, couldn't you, this way, or you could just go that way. And the logic just means that you'll have the same outcome whatever happens. That was strange.
Although you can do that.
It would also be the mistake. You want to go all the way across. Thank you, people. Okay, and now we need to simplify. Now we've got a box of 8 inside, which will mean it's how many variables? 1, absolutely. So remember, we're looking to see what stays the same or what changes. Does C stay the same? Does D stay the same? Does A stay the same? Does B stay the same? I know we only said it's 1, so we had it straight away. So the variable it will be is D. And then the next box I'll connect up with an OR. So it's one of these few times we've not done something with brackets and connected with ands. And then shall we do yellow? So yellow has not changed particularly. Well, what do we think yellow's? Sorry, what do you think yellow's going to be for this one? It's 4, so it will be 2 variables. So yeah, A changes, B doesn't change, so it is B, and C also stays consistent. So we're talking about B and not C. And then finally, for our last one, for our green box, yeah, A and B. This is the last one I was going to do with you guys in this format, simply to sort of like try to push it out there a little bit. But remember, it's all about Boolean simplification. Look how simplified we have managed to make that. The difference is colossal, isn't it? And imagine if this was a logical circuit. This is a considerably less complex logical circuit. Or if it was a programming code and you've got a bunch of if statements stacked up to replicate this, right? That's what this could be. That is an awful lot simpler and therefore would process faster. We've got lots of advantages. For the final question, I kind of flipped it a bit. I've never seen a question like this, but I could anticipate a question like this happening. What you have on the right is the original logical circuit. You have the original logical circuit. So stage 1 would be to turn this into Boolean algebra. So you need to take that logical circuit there, turn it into the Boolean algebra, then put it into the Karnaugh map. If you can do that, go ahead. Although I'm thinking like how it could be in an exam question. I could see how they could give you a logical... Here's how I could see this as a big marker. And if I predicted it correct for your paper in the future, then I've got it recorded that I did that, right? I could see that you could be asked to do something like that, turn it into the Boolean algebra, the Boolean notation, because Boolean notation is part of, one of the things you need to do. Then simplify on the Karnaugh map, and then redraw the logical circuit. Simplified. Okay? Best of luck. So stage 1 is me trying to rewrite this in Boolean algebra. And what I'll do is I'll take each of the terms in turn, each of the logic gates rather, and as always I'll work from the left, you know, write that out, and then that's the inner brackets and work out from that direction. And let me just, what am I doing? Here we go. So we've got this top one here. A, not A, is going into this AND gate with not B. So I'm going to start off with that. So I've got not A and not B going to the AND gate. And then if you see here, they're both going to go into an OR gate. So this AND gate is going to go into this OR gate. And then this AND gate is going to go into this AND gate. So I'm going to find out what this is. So this is A and not B. So I'm going to do an OR. So it's A and not B. And then all of these are going to go into an OR gate. And on the other side of the OR gate, we're going to have this. So I'm going to start with this AND gate here. So this is not C and D. And then that's going to go into this OR gate. So I need to find out what's on this side. So on this side, it will be what we do, not C and D. To simplify this expression, we're now going to place it inside our Karnaugh map. So I'm going to do the same as I did before and highlight. We've got not A and not B. So that's going to go all the way across this top row. Then we've got A and not B. So that's going to go all across the bottom row. And then we've got not C and D. So that's not C and D. So that's the second column down. And then finally, we've got C and D. So that's the column next to it. And we have an opportunity now to simplify. Remember, as always, largest boxes we can make of 1, 2, 4, 8, and 16. As few boxes as possible, and making use of overlapping and folding to achieve that goal. So I'm going to draw the two boxes, one in the middle and one folding around this way. And remember, since there's 8 in this box, and the boxes will be in a 4-variable Karnaugh map, how many variables will be identified with an 8 box? Just the one. So remember, we see what stays the same. C does not stay the same. D does stay the same, so it must be D. You can see here that A and B are different, so it's going to be D. And then the other one, we have to look at what stays the same. A changes, B stays the same. So it will be, and it's not B. What's the combination? What's the thing between it?
OR gate.
OR gate. So now, if we were to draw our circuit, we would draw it differently. Okay, so I've had a go at trying to draw the circuit, and I've drawn an excellent OR gate. What have we just done? What have we just demonstrated that's different from before? That was the original logical circuit, wasn't it? And we're saying that we can achieve the same as that with this. Neat, right? Yeah. Okay.